Hello, yes, Evan. So we're going to do a little revision video all about series and parallel circuits. So a bit of a recap on series and parallel circuits. So far in the course, you'll have looked at two different types of circuits, series circuits and parallel circuits. We've got an example of a series circuit on the left here and an example of a parallel circuit here. Have a little bit of think about the features that are different and the features that are the same in these two circuits. And if you can, just make a note about them. So as you'll have noticed in the series circuit and in the parallel circuit, they're both powered by one cell, okay, or you might call that a battery. And in each case, they've both got two bulbs or two lamps. Within a series circuit, those lamps are connected in one continuous loop, one continuous circuit linking the lamps to the cell. In the parallel circuit, there are two loops. There's a loop connecting the first bulb and there's a loop connecting the second bulb. And that's really important. And we'll look at why that's important in a second. If we look at the diagrams, the circuit diagrams, we can see that if we put our finger on the series circuit and follow the electricity around the circuit, it has to pass through the first bulb and then the second bulb before it can get back to the cell. If we do that with the parallel circuit, as we put our finger on the wire, the electricity has an option at this point. It can travel along the first branch or it can travel along the second branch, and indeed the second branch is connected to the cell completely separately to the first branch, and that's important. So the two types of circuits that we're interested in, series circuits and parallel circuits, and I think it would be useful if you were to draw those two circuits and write the names of them in your books or on paper. So the things are the same, two cells. But the key difference is that in a series circuit, there's only one route for the current to flow, but in a parallel circuit, the current can take different routes. The series circuit's got 3 wires and the parallel circuit has 4. So write down the key differences between series and parallel circuits and really make the point that in a parallel circuit, the current can pass through different branches, whereas in the series circuit, there's only one loop that the current can travel through. So you can pause the video and you can do that. So something for you to have a little go at now are these series circuits or parallel circuits. So pause the video and just make a note as to whether or not you think A, B, C or D are series or parallel circuits. And remember, what you're looking for is putting your finger on the cell, following the electricity around the circuit, and if the electricity can travel all the way around the circuit without you having to remove your finger, then it's a series. If you come to a branch, then it's a parallel. So pause the video and try that now. So let's look at the answers. So for circuit A, it's a parallel circuit because we've got a branch at this point. Circuit B is a series circuit because there are no branches. Circuit C is also a parallel circuit. We've just got the switch in a different place. Sorry, start again. Circuit C is a series circuit. We've just got the switch in a different place. And circuit D is a parallel circuit because again we've got a branch and the electricity can go through that branch if needs be. So that's a parallel circuit. So the general rule then for current in a series circuit. In a series circuit, the current is always the same all the way around the circuit. So the reading on ammeter 1 in this circuit is 4 amps. What do you think the reading would be on ammeter 2 and ammeter 3? Look back at the rule for the series circuit. So yeah, so in a series circuit, the current's the same everywhere. So if ammeter 1 is 4 amps, then ammeter 2 is 4 amps and ammeter 3 is also 4 amps. So make a note of that rule, please. Just write that down. The current in the series circuit is always the same everywhere. Let's look at a parallel circuit. So in a parallel circuit, the rule for current is the total current in a parallel circuit is equal to the sum of the currents to each path. So what that means is the total current in the circuit is equal to current along this branch and along this branch. Okay, so let's have a look. The reading on ammeter 1 in the circuit is 4 amps and on ammeter 2 is 2 amps. What would the readings on the other ammeters be? Well, we've got 4 amps coming out of the battery, or out of down that line there, down that wire. 2 amps goes along this branch, 2 of the 4, and that leaves us with another 2 amps that can go along this branch, and both of those 2 amps connect up to become 4 amps before they go back into the cell again, or back into the battery again. So we've got 4 amps coming out of the battery, 2 of those 4 amps goes along the first branch, 2 of those 4 amps go along the second branch, and both of those recombine to give us 4 amps going back into the battery. So, oops. Let's just look at these for the time being. So all the bulbs in a series circuit are on or off together. Well, that's true. If in a series circuit one bulb goes off, the electricity can't get past the broken bulb. If you break a bulb in a parallel circuit, the other bulbs stay on. Well, that's true because in a parallel circuit, just go back a second, if this bulb breaks, the electricity still can travel down to this branch, so this bulb will stay on. The current in the series is the same everywhere in a parallel circuit. That's not true. In a parallel circuit, the current is shared between the branches, and the current in a parallel circuit splits up when it comes to a join in the wires. That's absolutely true. It does. Okay, so something for you to try now. Then, got 3 questions. Read through these questions, and then have a guess at what you think the answer might be based on the information that we've watched so far in the video. So, which of these circuits are parallel? That's question number 1. Which switch must be pressed to make bulb X come on? Okay, and then which of these statements is not true? So pause the video and have a little go. Okay, let's look at what your answers would be. So for number 1, clearly X and Y are both parallel circuits because they've got branches. For number 2, if we close that switch, the electricity can get across that gap, and it needs that switch closed for it to continue its loop. So it's 1 and 2. If we closed 3, then obviously battery bulb Y would work, and we don't want that. And then which of these statements is not true? The current at Q and R add up to give S. Well, we know that's true because it's a parallel circuit. The current is the same at P and S. That's true because that's the current going in and coming out of the cell. The current at Q and R are going to be the same because they're the same bulbs. The current gets split between the branches equally. So the thing that's not true, the current is the same at P and Q. We know that's not the case because the current coming out of the cell gets divided between the branch with that bulb on and the branch with this bulb on. So those two, P and Q, must have different currents. Thank you very much for watching.